Hello students, welcome back to my channel. Today I will discuss about supersonic and hypersonic. First I will establish these terms, then I will tell you the difference between supersonic and hypersonic. So let's start. See, first it's important for us to establish some terms like hypersonic is obviously supersonic on steroids. But while supersonic has the clear-cut definition of being faster than the speed of sound, that is Mach 1, hypersonic is little fuzzier. Generally, hypersonic speeds are the point at which the molecules of air that surround the aircraft start to change by breaking apart, that is dissociation, and or picking up electric charge, that is ionization. These things don't happen at one particular speed. So the term hypersonic instead refers to the point at which they start to meaningfully affect the mechanics of flight, generally accepted to be Mach 5 or 3836.35 mph in conditions of 20 degrees Celsius at sea. The rate at which object travels faster than the speed of sound is expressed in terms of supersonic and hypersonic speeds. Such speeds are measured in terms of Mach. Mach number is defined as the ratio of speed of the aircraft to the speed of sound. Supersonic and hypersonic are the two main types of speed of flight. Though four general categories define the speed of flight, that is subsonic, transonic, supersonic and hypersonic. Each is relative to a Mach number, but here we are not going to discuss about subsonic or transonic that I will cover in another video, but at present I will be covering supersonic and hypersonic. Is the supersonic speed. Now, supersonic speed is the rate of travel which exceeds the speed of sound, also referred to as Mach 1 speed. Since the speed of sound depends on temperature and composition of air, supersonic speeds also varies with changing altitudes. In water at room temperature, it is greater than 1440 ms. While in solids it is even more. An example of supersonic is a bullet fired from a gun. Fighter planes and space shuttle also fly at these speeds. Concorde is the only passenger aircraft at travel at such speed. This is of France. It took its last flight in 2003 and it is not in use now. The term sonic boom is associated with these speed. When an aircraft flies at this speed, a person on the ground hears a very loud noise, which is called sonic boom. Sonic boom is produced as a result of the movement of the air molecules under a tremendous force. Next, hypersonic speed. Now, hypersonic speeds correspond to very high supersonic speeds. They are basically Mach 5 speed or 5 times the speed of sound. The speed of a hypersonic aircraft is around 3000 miles per hour. These speeds are again of three kinds: low hypersonic, hypersonic and high hypersonic. X-15 was the only manned aircraft to fly at low hypersonic speeds, that is at Mach 6. During its re-entry, space shuttle also acquired such speeds. The distance between shock wave generated by a hypersonic aircraft and the aircraft is smaller than in case of supersonic aircraft. In brief, we can say supersonic is Mach 1 speed, while hypersonic is Mach 5 speed. Supersonic speed is greater than the speed of sound, while hypersonic is 5 times the speed of sound. The reason for the distinction between supersonic and hypersonic is due to temperature changes. At speeds above Mach 5, most metals will melt or become so soft that they can't be used for any type of structure. As a result, hypersonic aircraft must go to extreme measures for heat protection, such as the tiles and blankets protecting the space shuttle. While it's challenging to imagine what happens to an aircraft at such temperature, here are two examples. Aluminium will melt at approximately 1200 Fahrenheit or 648 Celsius, and steel will melt at approximately 2500 Fahrenheit or 1371 Celsius. Sometimes students ask, is there any difference between supersonic and hypersonic flows other than the Mach number? Yes, hypersonic flows present some physical phenomena that are not seen in supersonic flows. These phenomena become more important as the Mach number increases above 5. In hypersonic flows, we can observe thin shock layers and the formation of thick entropy layers. Also, the viscous interactions adds more complexities in the boundary layer region. Furthermore, high speed leads to high temperatures that produce ionization and dissociation of the gas around the moving body. I hope you understood, and if you like, then please like, share and subscribe. Thank you.